Hello everybody and welcome back. I hope you're all doing phenomenal. If you've been following along with Cockpit build, when we started looking into PCBs, the first method didn't go so well. We tried the toner transfer method where we transfer toner into a PCB and we dunk it in an acid bath for a little while. While this method is used and it can be done reliably, I keep having traces eroded and I can't get reliable results out of it. So I put a pin in making custom PCBs and decided to do some breadboarding while I'm still in the prototyping stage, and then potentially use something like JLPCB or an online PCB manufacturer when I get to the stage, or got to the stage, that we needed some more. It's definitely viable to turn breadboards into usable circuits. It's just a huge amount of work. If you guys have seen the latest videos on that little red board, that took a huge amount of work. It was probably a good 6 to 8 hours worth of just soldering to get everything on there. There's ways that I could have shortcutted it, and there are easier ways to do it, but in general, it's just too much work. So that brings us to the newest attempt at being lazy. How about a CNC? It's a little baby CNC, but the etching needles on it have a 0.1mm tip, and normally the space between traces are 0.5, 0.6, and we can vary them. So we should have plenty of precision when it's calibrated properly. But when I first got it, I had a bit of fun putting it together. There were lots of little parts. It was well organized, easy to put together, well packaged. And there are a couple of YouTube videos out there that are super easy to follow, and they cover pretty much everything you need, from starting, setup, how to actually use the thing, etc. So there's a pretty good amount of support out there on the community, and a lot of people have used this thing. And once the grand building conquest was completed, it was time to turn it on and figure out how it worked. Not gonna lie, I was incredibly disappointed. I started with plugging in the offline controller, just gonna do some jogging on it, and trying to see how the machine even moves. And the controller just constantly locked up. It required machine resets, and the buttons and controls are not intuitive in the slightest for even how to use it. I actually accidentally managed to figure out how to do the back button by holding enter, which is usually your go button to enter whatever you're working on, but they don't put the instructions on there. There wasn't a back, an enter, an okay, etc. It didn't use any standard conventions, but still doesn't. So, after a whole bunch of times with the controller locking up, the machine locking up, and not even being able to do a test cut because of how broken it was time to try the USB method. And that wasn't any better. So the recommended programs don't recognize the CNC, the online tutorial programs don't work, and the other option was to try something like Mach 3, which is recommended, but it's like $175 for just a personal license. That's an expensive trial. That's almost as much as the machine itself costs. So since the freeware wouldn't recognize it, we were kind of in a bind, and there was really only one option left: to plug in the Chinese USB with potentially malware or who knows what on it. But it worked out pretty okay. Plugged it in. There was actually a pretty good number of files on there. Some of them are CNC, some are stuff to cut out, etc. One of the files on there was actually a CNC control program, go figure, and it actually worked. So it took a little bit of configuring, a little bit of fussing around. I had to go into the device manager, unplug and replug the CNC a couple times to figure out what COM port it was on, and it was not the easiest or most intuitive way to set it up and connect to it and get it running. And honestly, I kind of never wanted to disconnect it because it was a pain. But once I got it set up and running, then jogging was pretty easy. We were able to do some Z-probe heights. We were able to calibrate the thickness of our probe and actually plug that into the machine. That way our offsets are correct. And it just looks like the company quietly switched programs and forgot to mention it. So the program itself is actually very slow. You have to be very gentle with it. If you give it too much at once, it just locks up and it's done. So after a little bit of messing around, we had it jogging around the park, we got into a little bit of probing, and we even got ambitious and designed a custom test piece. So with everything calibrated, set up, homed, and ready, it was time to put the new CNC to work and do some test cuts. And then, disaster struck. So as it turns out, it has a reverse axis, and zero's at the top of your part, not the bottom. So zeroing on the bed is definitely the wrong method. You have to zero from the top. And the instructions that come with it don't cover the operation of the machine, so either find a YouTube tutorial or something else. But the emergency stop button was used a lot to figure this out. But with proper zeroing, we were off to the races. And voila, one part of a zillion worked. So we have functionality. But where does this actually leave us? Well, I need to design some PCBs. I've completely changed the electronics between when we were originally starting with the PCBs and we were trying the acid etching method and now. So none of the original files that I've made before will actually work with the current cockpit in this iteration. So next up will be some PCB design and cutting, and if you guys would like some more frequent updates behind the scenes and some of the blueprints and CAD files of what we're working on, head over to the Patreon page. And with that, thanks for watching, and we'll see you guys in the next episode.